All right, so now we're going into simple and compound interest here, and I'm going to split this. Uh, no, I'm not. I'm just gonna do one big video. Yeah, I'm gonna do one big video here, but I do encourage you to stop it once you get to simple. Do that and then come to compound. Um, Now, again, you guys are all adults. I don't need to explain what interest is to you, right? Interest is the amount of money that's paid or charged when you borrow or deposit money. You guys understand that concept, right? If I take out a loan, I need to pay interest as a cost of, the benefit of, hey, this guy's going to lend me $10,000 to buy a car. I need to pay him $11,000 back, right? And that's for the privilege of taking money. If you leave your money in a savings account in a bank, it earns interest, right? And that is you doing the same thing to the bank. I'm giving my money to the bank for them to use for loan purposes. And in exchange, they're going to give me a little bit of extra money every month as interest. Right now, most interest is usually used during like a lot of interest is used with simple interest. There's a difference between these two. Compound is often used for things like credit cards and payday loans, as an example. Um, Whereas simple interest might be used more for like a car loan, for example. Mortgages are kind of weird. It depends on where you're from, and so on and so forth. I'm not going to deal with that. That's more of a financial literacy class thing. So we're not dealing with mortgages because there's a lot of background information, as much as I'd love to. But what you do need to know is you do need to know the term principal, right? Again, if I give $1,000, if I do $1,000 loan, that is the principal, which we say is P. The term is the length of time. So maybe it's for 2 years is the term. And that would be, we say that's T. Now, one thing I want to note is it's the length of time in years. So this would just be 2. If I were to do 6 months, well, that is half a year, 0.5. Or better yet, 1 over 2. Fractions are going to be your friend in this section from this point onwards. So this is half of a year. So that's an important aspect here. It's the length of time in years. Now, we usually say per annum, which means per year. So you're going to see this a lot. We're going to be using some more official terminology here. We're also going to see things like quarterly, bi-weekly, semi-weekly, bi-monthly, semi-monthly, biannually, semi-annually, and so on and so forth. We're going to be seeing these terms, so it's important to know what these all means. Now, simple interest has a formula where it is the interest I is equal to principal times the interest rate as a decimal times the term as a year, right? So to find interest, which is the amount of interest earned or due, it's not the total amount, is equal to the principal times the interest rate times the term. Now I'm going to say I borrowed this $1,000 at 5% interest rate, which is 0.05 if I turn it into a decimal. Right? So in this case, my interest of this would be $1,000 times 0.05 times 2, because it's 2 years, right? And so if I were to punch this into a calculator here, $1,000 times times a 5% interest rate, which is 0.05, times 2. Hey, I've paid $100 in interest. $100 in interest, which means in total, I need to pay back $100 plus $1,000, right? It's $1,100. That's my total amount I need to pay back for this $1,000 loan over a period of 2 years. And that's what simple interest is, right? It doesn't really get much deeper than that. Um, if you want to know this figure right off the bat, you just add up the principal and the interest, right? Here's the interest, here's the principal. Hi, Cat, get away from my computer, please. Um, yeah, so that's what it is. I don't feel like I don't need to go too much more deeper into this here. As an example here, again, I is equal to PRT. My principal is $5,000. I've invested $5,000. It offers simple interest. These are keywords you're looking for. I'm investing 5,000. It offers simple interest. I want to know how much the investment would be at the end of each of these rates. Read the question carefully. It's going to screw you if you don't eventually. So it is $5,000 times my interest rate, which is 3%, which is 0.03, right? Move the decimal place twice. If you don't know how to do that, just put a bunch of zeros in. 0.0003, right? All I did was I just added all these bunches of zeros. 1, 2. It's now 0.03. And then these zeros come down, but like they don't actually matter in this case because they're zeros. So there it is. There's my interest rate times 2 years. So 5,000 times 0.03 times 2 years, $300 in interest. Yay, I'm done. No, you're not. Read the question carefully. How much would the investment be worth? And my investment, again, is my principal, which is $5,000, plus my interest, which is $300. My total investment is now worth $5,300. So read the question very carefully, please. Um, and then you guys can try this one out here. One thing I want to note here is look at this one. Look at this. Remember, it has to be expressed in years. What's the easiest way to turn this into a year? Now, you could use a decimal. Don't. Just keep it easy for yourself. I promise you, you're going to give yourself a pain in the ass if you're using decimals. Every single answer you give will be wrong. You must use fractions here. You have to for this unit. So how many months are in a year? Well, there's 12, right? Well, I have 15 months and there's 12 months in a year. I've expressed this in terms of years, right? This is 15 over 12 years, which we know is, well, that's 1 and 3/12, which is, it's 1 1/4 years. Either of these are all the same thing, but this is the easiest way. Use that. So instead now you'd get $5,000 times 0.175 times 15 over 12, right? I can do that. Sure. As a reminder, it's been a while since we've maybe used our fraction button. 5,000 times A/B button. Oh, sorry. No, I don't need that yet. Times 0.0175 times now fraction button 15 over 12. Move your arrow over. $109.30. Well, I can't have 37.5 cents, right? I can't have half of a cent. Just round it up or down. I don't care in this case, but properly we would round this up. So $109.38. $109.38 would be the total interest. Add the $5,000. My total investment, because remember, you got to read the question right. It's $5,109.38 here. And you can see the other answers down here as well. Wait, what? Oh, that's B. Okay. All right. So in this case here, I want you guys just to do this. I'm not even going to go through it. I trust you. I'll go the answers up here on screen. So 3, 2, 1. Okay, so for question 1 here, for example, one thing I want to note is that it asks you for just what the amount of simple interest earned is. It's not like up above where it wants where it wants the investment. No, it just wants the interest and that's it. So you do your I equals PRT thing, you plug in the numbers, and these are the numbers you're going to get. 25, 50, 50, 50. Now for question E, what happens to the amount of interest earned when the principal and the term stays the same, but the rate doubles? And if you're like, well, I don't know how I'm supposed to know that. Well, put some numbers in, right? Let's put $1,000 in. Let's times it. So principal, $1,000. We're going to say it's for 1 year, and we're going to do a 5% interest rate. We're also going to take the same thing. So same principal, same year, but now it's going to be for 10% interest rate, which either of these works, right? Either of these works. Same thing. Well, in this case, it would be $50. In this case, it would be $100. It's doubled. And the same thing happens here as well. If you really want to learn why, I do encourage you to take do that same thing. Now for question 2, you want to calculate the value of an investment after 600 years. So I will throw in the answers here for question 2 and 3 in a second. So 3, 2, 1. Now for question 2 here, it should be $712.50, right? It's the investment. There's $112.50 of interest. Add the $600 of your principal in there. Now you get the investment. Now for question 3, how much money would you have? This is an investment. If you have it for 10 years, $1,000 at 4.5% interest rate per annum, per year, right? Per year. And that means it's calculated once per year. We'll get into that later. Well, you would end up having was it? Yeah, $1,000 times 10 years times 0.4045. That make mis sorry, it's supposed to be times 1,000. I'm like, that's not right. $450 is my interest. But remember, I got to take my principal plus the $450 of interest. $14.50 is my total amount invested. This is how much money I have left at the end of the day. All right. So at this point, I'm now going to start going into what compound interest is. Now, the difference between simple and compound interest is that, if I look at this one here, and I did it for 10 years, right? Well, after year 1, this would be $45 of interest, right? After year 1, it'd be $45 of interest, which means I have $1,045. But for year 2, I'm no longer calculating it on $1,000 principal. No. I have $1,045 in. So maybe now I'd get $46 of interest. So now I have $1,091. Now for year 3, I don't have $1,000 invested. I have $1,091 invested. So maybe now it goes up to $48, and so on and so forth. So that's what compound interest is here. So compound looks at the interest that is calculated on the principal. So it counts that extra little bit of money plus any interest previously earned, right? So it counts that little bit of extra money. It's the interest calculated on the principal plus interest. So again, just like up here, there's an extra $45 here to calculate that interest on. There's an extra $91 here to calculate that interest on. So now at the end of it, instead of $450 of interest, maybe now I have $500, and now I have a total of $1,500. So that's how compound interest works here. Now, this is where normally, for simple interest, it's per year, right? Yeah, per year, that's fine. Now, for compound, we have different periods. So maybe up here, the interest was calculated every year, right? What if I said it's calculated once a month? Well, now it's $1,000 and $4.50. Then maybe month 2 is $1,000 and $9.20, and so on and so forth. And eventually, after year 1, I might have $1,047.50. So how frequently you compound that matters here. So that compounding period is important because it is the time between the calculations of interest. Now, this is where we get into some terminology. Semi means twice per. Semi-annually means twice per year. Semi-monthly means 2 times per month. Okay? Quarterly is 4 per year, right? It's into quarters, right? Monthly is 12. Daily is 365. Now, there's something missing here. You might have weekly, which is, of course, 52 periods per year. But you might also have bi-weekly. Now, if If semi means 2 times per, bi means every 2 times, every 2 months. So semi-monthly is 2 times per month. Bi-monthly is every 2 months. Or maybe I do bi-weekly. Well, that's every 2 weeks, right? Well, isn't this the same thing? No, because bi-weekly every 2 weeks, there's 52 weeks. This is 26 times. Whereas semi-monthly, 2 times per month, there's 12 months in a year. Doing it twice per month, 24. So it's a little bit different. When you take a new job, a lot of people are like, you'll be paid semi-monthly. Well, no, you're taking that extra 2 paychecks and you're spreading a little bit of it out each time. So that's just important to note here. So you do need the terminology here. Now, one thing I want to note is that interest formula. For both of these, that's going to be given to you. You do not need to memorize the interest formulas. This is a good time to just go back into the very start of the course and look at the formula sheet I put on there because you'll be given a lot of formulas. But you do need to, one, know the difference between, like, you need to know what semi-annually and quarterly and bi-weekly and bi-monthly and semi-monthly mean. You need to know what all that stuff means. You also need to know that, like, the I is interest, the P is principal, the A is your investment, R is interest rate, and you need to know how to, like, 5% is 0.05. So those are things you need to know, that you need to walk into the final exam with. You will be given the formula, but you still need to know how to apply it. Okay, so this is the formula. It's a lot more complex, but we'll work through it. So A is your investment. So your investment is equal to the principal, and it's 1 plus the interest rate divided by N. N is the number of compounding periods. So if I said it's compounded monthly, it would be 12 in this case. And then it's to the power of N times T, okay? N times T. So for example, if I give you $1,000, sorry, your principal is 1,000, your interest rate is 5% or 0.05. I'm going to say N, it's compounded monthly, so 12. And T, it's done for 5 years. Oh, we have a car loan here. This is what car loans are, right? 5 years. Here's the interest rate. Here's the principal. Yay. So if I were to give you this here, well, my investment, A, would be equal to the principal, so 1,000, times 1 plus R over N, 0.05 over, it's done monthly, to the power of N, which is monthly, 12, times T, which is 5 years. Sorry, important to know, in years. Really important to know. So this would be what I would put into my calculator here for an example. So if I give you $1,000 as a loan, so you put it in exactly like this. So again, you need to use stuff as fractions or you're going to get hilariously wrong answers. It matters for this unit. I know some of you have been trying to use, like, I will round it to 3 or 4 decimal places. You cannot do this here. It will blow up in your face. To the power, how do I do the power? This thing here, yx to the power of 12 times 5. Now you could just put 60 here. You'll get the same answer, but I do encourage you to do it this way. It's easier to spot mistakes. So I do that. My total investment is $1,283.36. So $1,283.36 is my total investment. This is not the interest. This is the investment. If I were to ask you, what's the interest on this? Well, you just take away $1,000, Matthew. Correct. It would be $283.36 would be the total interest on that thing. So that's what compound interest is. Now we can make it a little bit more complicated because what if I just ask you, hey, here's your principal, here's your investment, what's the interest rate? So you can work backwards that way. All right, so so I want you guys to try this one here. Try out question A. So $1,000 deposited. It has pays 4% interest per year. It's compounded annually, once per year, and it's left for 2 years. So try that out. Pause the video now. 3, 2, 1. Well, so again, my investment is $1,000 times 1 plus what's my R interest rate? 0.04 divided by how many times it's compounded in a year? Once. All to the power of, remember, to the power of n, which is number of compounded periods per year. Well, it's just compounded once per year times how many years? 2. So 1,000, sorry, not plus, times 1 plus, wait, right? Am I doing that right? Yeah, plus. Uh, plus 0.04 over 1. Use your arrows here. Arrows are important now, right? Because you need the bracket. You don't need the bracket to go here. That's going to cause problems. You need the bracket to go here. To the power yx button of 1 times 2, or you can just put 2. $1,081.60. $1,081.60. Now, one of the key words here is you're going to see compounded, because sometimes you're going to see ones with simple interest. And now this wants us to compare it. So this is the interest I would earn. I haven't answered this question yet. The actual interest I would earn would be $81.60. Now, what if it was simple interest? Well, I equals PRT, right? 1,000 times the interest rate times the amount of term. What does the T mean? What does the T mean again? The terms of the investments in years. So 1,000 times 0.04 times 2, $80. So you can see here that actually the compound loans and investments will earn money quicker, or sorry, they will grow quicker. If you have a compound loan, that debt will grow quicker. If you have a compound investment, that investment will grow quicker. Now, this doesn't seem like a big difference, right? It's $1.60. Who cares? When you factor in like something like a car loan or a mortgage, which are 5 and 25 years, or you're looking at massive amounts of money, like for example, investment bankers, your random, the worst investor you know manages a portfolio of millions of dollars. And this is other people's money, right? They have other people's money, they group it all together, and that's how they do their investment. But that adds up significantly. And what if it's compounded monthly, like a credit card? And in fact, I want to go do that. I want to go into monthly. So I'm going to my calculator. So now I'm going to actually do, instead of 12, it's going to be, so instead of 1, it's going to be 12. Instead of 1 times 2, it's now 24. Sorry, it's 12 times 2. It's 24. Oh, it went up to $3.14 now instead. So the interest actually doubled in this case. Again, with $1,000, yeah, whatever. That doesn't, it's not a couple dollars, but $1,000,000. Oh, that's a lot of money. That's that's like 10,000. That's like $15,000 there. Um. Okay. Now I do want to do question 4 here with you, but I want to do the. I want to show you what's actually happening here. You don't have to do this every time. Actually, you're probably going to have to do this at some point, so it's good that you show you. Now, for question 4 here, I want to know the final value. So the investment A of $5,000, P invested at 3% interest rate, R compounded annually, N for 2 years, T. That's how you should be reading this. Now, instead of doing my formula, I'm going to instead just kind of do it like this. I'm just going to do 1 year at a time, or one interest period at a time. And it compounds yearly. So I'm going to do simple interest here once a year. So I equals PRT. I know it says it's compounded. Trust me, I'm lead into this. PRT, principal. So it's $5,000 times interest rate of 0.03 times 2 years. If I do that, I should end up with, I should just be able to do this in my head. I mean, I can, but just want to double check. $300. Yeah, that's what I thought. So I now have yada, yada, yada. I have $5,300, right? So this is year one. Now for year two, I have $5,300, right? Because that's what I'm entering year two with. Oh, sorry, I've goofed this up. This is supposed to be one. Right, 150. My bad. My bad. Times one. So now I'm doing that same calculation. So 150 times 0.03 times 1. I get 154 and 5 cents, right? So 150 plus 105, 5 cents. I will have $5,304.50, right? So that's what's happening here with compound interest. It takes this calculation, because what if I told you this is compounded monthly for 25 years? This is a mortgage. You would have, was it 25 times 12? You would have 300 of these. You'd have number one, two, all the way to 300, right? So you do it all in one simple calculation instead. That's why we use that compound interest formula. To make sure I'm right, though, I'm still going to use that same formula anyways. Right? So always a good idea to go and check the formula out. I do recommend you just write it down separately on a piece of paper because it's just an easy way to remember it, right? A equals P. Oh, where am I? Oh, A equals P 1 plus R over N to the power of N times T, right? A equals, what's my principal? $5,000 times 1 plus my interest rate is 0.03. It's compounded yearly, so I put a 1 there to the power of N, which is 1 times 2 to the power of 2, right? So let's double check my math here. Plus 1, sorry, not plus, times 1 plus 3 over 1, all to the power of 2. Oh, $5,304.50, right? So my investment is $5,304.50. So it's the same amount. So this is how compound interest up here works. It's not just about knowing the calculation, it's about knowing how compound interest works. That's the important part here. Okay. So at this point, I trust you guys to be able to really do everything here for questions 5 and 6. So I trust you guys. You guys can do that. I'll put the answers up here in 3, 2, 1. So here's the answers. Now, one thing I want to note is I didn't get 1487. It's the difference between these, right? Take this one, right? Let's call this A. Then we'll call this one down here B. Take A, subtract B, right? That's how you're finding the difference between them. The compounded one should be $14.80, 87 cents more valuable. That's how I got that. For question 6, it's $1,051.20. 27 cents. All right. So now we're going to swap the per year part, and we're going to look instead at semi-annually, quarterly, and monthly, right? So A is equal to my principal, which is 1,000, times 1 plus, what's my interest rate? 0.028 divided by semi-annually. Semi means twice in a. Twice in a year is, well, twice in a year. To the power of N times T. I know my N is 2, and I know it's for T, it's for 4 years. Right? $1,000 times 1 plus fraction button, 0.028 over 2. Can you see now why you need fraction buttons for this one? You have to stick with the fraction. All to the power of, well, 2 times 4 is 8. 1,000. Sorry, just right, moving this over here so I can see it. $1,117.64 cents. Cool. So now let's do it quarterly, right? It's the same thing. Same amount of money, same length of time. 1 plus 0.028 divided by quarterly, 4 times in a year. All to the power of t times n, right? Well, t, how many terms? How many times is it compounded? It's 4 times 4, 16. So if I go into this, instead of 8 now, it's 4 times 4. Instead of 2, it's 4. 1,018.08. Now let's do it monthly, right? So now, copy and paste this in here. So now instead of it's being compounded 12 times a month and 12 times a month, right? So now I go back into it. 12. It's 12, backspace, 12. $1,118.37. And 37 cents. So you can see the more we compound, the higher it gets. Now that said, at a certain point, those gains become less and less. So like, this went up, was that 42 cents? This one here only went up 29 cents. So the more you compound, the less increases in the gains there are, but it still increases overall, if that makes sense, right? The rate at which it increases just starts to decrease. So at this point, I trust you guys to be able to do this stuff. Try out question 7 and 8. I'll put the answers up there in a second. So 3, 2, 1. Okay, so for question 7 here, you can see the answers. So we want to know the final value, so the investment. If we have a principal of 4,000, a rate of 0.04 as a decimal, right? Per annum, so per year for 8 years, and it's compounding. So there's a lot of keywords there. So this should be your final answer there. And again, as you can see, the gains, the more you compound it, it goes from once a year to twice a year to 4 times a year to 12 times a year. The more I compound it, I get more money, but the gains slow down. For this one, it's like, what is that? Like $17, something like that. But then to go from here to here, it's like $8. Then to go from here to here, it's like $6. You're still making money. It's just you're not making it as fast anymore the more you compound, okay? But you still make more. Now, you're going to eventually look into payday loans here. That's going to be part of 5.2 as an assignment. And oh boy, I don't like to swear much, but holy fuck. They're going to have something like, sure, I'll lend you $1,000. Principal's $1,000. But the interest rate is going to be 365%. For reference, that's that as a decimal. And it's going to, compound daily. So 365. So if I give you that for an example here, right? I actually want to map this out for you. And let's just say, screw it. We're going to say it's a month, 1 over 12. 1,000 times 1 plus R. My R is 3.65, right? That is 365%. That's actual rates. Like that's not some obscene thing I'm doing. Now, n is 1 over 12. So I have to put a fraction in a fraction here, right? Wait. Oh, sorry. How many times it compounds in a year? Sorry. No, I'm lying to you. It's 12. Just 12. No, it compounds 365 times. My bad. But the term of the loan to the power of 1 over 12, right? Because it's just 1 month. We still have to do it per year times 365 because it compounds that many times. You've paid $350 in interest here, right? Heaven forbid you miss a payment there, right? Like that's a real world example. That happens. You know those payday stores you see everywhere if you ever go to the cities, there's a reason they're there. It's because they screw you. Like I would rather rob money and risk going to jail than I would go into them. All right. We're almost done here. Question 8 here. Calculate the value of an investment. Come on. Of $5,000 that earns an interest rate at 2.095. Sorry, 2.95 per annum. It's compounded semi-annually. Semi means twice per year, twice for 3 years. T. Sorry. N. This is T. Show the value of the investment at the end of each compounding period, right? So every time it compounds, so twice a year times 6 years, six of them. So you can see this here. I'm not going to actually do it. This is what I did way up here, just a little bit deeper, right? $5,000. I got this much in interest. At the end of this investment, this is what it's worth. So now I'm calculating that now I have this as a principal. So you can see it's gaining a little bit more, right? It goes from 74.84 to 25.94 to 77 to 78 to 79. So whereas simple interest would just use this figure every single time. Now, and again, this is a lot of work, which is why we use our formula. You get the same answer here. You can see it's the same bloody answer. All right. So at this point, I trust you guys. You should be able to do that. You should be able to do this. You're good to go. Sorry, I lied to you. Now, one more thing. The rule of 72. It is a way to estimate the time it takes for an investment to double the value. How long will it take $1,000 to turn into $2,000? That's what it does. It figures out that how long part. Could be $1 to $2, could be $1 million to $2 million, could be 5 to 10. It's just doubling the money. How long is it going to take? It's a pretty easy concept here. If you're investing your money, if you want to try and figure out how, you want to try and figure out how long is this going to take, if it's compounded annually, you just use the rule of 72, right? How do you do this? You take the approximate time in years to find that. You divide in 72 by the interest rate expressed as a percent. Oh, that's a wordy thing, right? But here it is. So how long is it take to double? I take 72 and I divide it by the interest rate as a percent. So for example, if I give you a 4% interest rate, I'm not having it. It's not 0.04 in this case, right? As a percent. 72 divided by 4, it would take 18 years at a 4% interest rate compounded annually to turn $1,000 into $2,000. That's how that works. You can check it if you want, but you're fine. And I honestly, I trust you guys. You guys can do this. You're fine. There should be no curveballs here. So at this point, you guys should do the assignment. There's going to be a secondary assignment with this though.